Hello. Today we are entering Chapter 10, which is the second half of hypothesis testing. So in the previous chapter I introduced the hypothesis testing framework and some basic terms and the decision rules, three different decision rules to make the decision. Here, one of the some important concepts was that first, null hypothesis is believed until proven wrong, and only when there is enough evidence against the null hypothesis, then we reject the null hypothesis and accept the alternative. To make so there are only two kinds of results. One is to reject the null hypothesis, and the other is not reject the null hypothesis. And when you decide whether to reject or not, there are three different methods. One was p-value, and another was t-statistic, and finally we could use critical values. So they are equivalent to each other. No matter what you use, you have to get to the same result if you use the same data, but one may be more convenient than another. Or when you read research articles about statistical results, you may see different results in different contexts. So it's important to understand all of them. And we are going to consider two additional topics in Chapter 10. So in this chapter, we are going to study two topics. Actually, they are quite independent topics. Like on Tuesday, we are going to discuss the first part of this chapter, and on Thursday, I'm going to discuss the second part of this chapter. The first part is about error probability. So what I did in the last lecture was to just define the decision rule. So I just declared we are going to reject the null hypothesis in this case. But I did not say anything about its accuracy or how much we can believe or how many errors can happen. So the first half of Chapter 10 is about the error probability or evaluation. It's to evaluate how accurate, how good the hypothesis testing works. And the second half of this chapter, we are going to consider totally different types of hypotheses. Like in previous chapter, we simply considered the null hypothesis is given by the mean equals to something, number, and the alternative hypothesis is different from that value. But we may use inequality. So in this chapter, we will consider one-sided hypothesis, which involves inequality rather than equality or like negation of equality. So anyhow, these two topics are the main two topics in this chapter, and we will study one by one. So let's think about the error probability. So so the first example I considered, the first analogy to hypothesis testing was the presumption of innocence. You may remember the null hypothesis is that the defendant is innocent, and the alternative hypothesis is that the defendant is guilty. By the way, I changed the slides because somehow I encountered errors when I make a PDF file with the new template. So I'm using the old slides that I used to use in the classroom. So content is pretty much the same. But you are going to see a little more I-clicker questions. This kind of questions in the classroom. I actually have students answer to these questions. But on online, I reduced the number of the questions. But in this slide, and maybe if it does not work, the error is not fixed, maybe till the end of the semester, you are going to see more AECO questions. It's not bad. You can just check if you are following by answering these questions. And always you can stop the video, pause the video, and try to answer it. Anyhow, like, sorry about the digression. Back to this example. So the defendant in any like criminal trial, the defendant is believed to be innocent until there is enough evidence of guilt beyond reasonable doubt. So that's the one of the main principle in modern legal system, and we can use the same analogy here again. In the legal procedure, in the criminal trial, there are two potential errors. One is an innocent person sent to jail, and the other is a guilty person set free. And each type of error is referred to as the type 1 error and type 2 error. I don't like the names. There is no reason for this to be 1 and for this to be 2, but it's not my fault. It's the convention. Even I am confused because I don't know, is it 1 or is it 2? There is no simple way to, there is no rationale behind it. Just memorize. Sorry about that. Anyhow, type 1 error is to send an innocent person to jail. So like sentence, so mistake of innocent person as guilty. Then in our terms, how can you generalize the definition of type 1 error? Using our terms like null hypothesis and alternative hypothesis. Think about this. 3, 2, 1. The answer is the truth is innocence. Actually, the defendant was innocent. So H0 was true, innocent was true, and even if though innocent H0 was true, but you rejected it, so it's an error. The answer is D. You are rejecting H0 when it is true. So the truth was innocence, but you rejected it and you thought the defendant was guilty. So type 1 error can be defined as a rejection of H0 when it is true. So in sum, you can consider 4 different cases. In terms of the result decision, it is whether to reject or not. So there are only two possible results, and there are 2 possible truths. Truth is either H0 or H1. So if H0 was true, then the correct decision is not to reject H0. Your belief was correct. So if you don't reject it, that's good. That's the correct conclusion. But if you reject H0 when it is true, then we call this type 1 error, as I defined earlier. On the other hand, when H0 was wrong, but H1 was true, in this case, the correct decision is to reject H0 because it is wrong. H0 is wrong, so you have to reject it if you made a correct decision. But you may not be able to reject H0. That's type 2 error. So the defendant was guilty, but you could not find enough evidence. So that's type 2 error. So some textbooks use all different terms. Type 1 error often referred to as alpha, type 2 error referred to as beta. But I'm going to use type 1 and type 2 errors as the terms to referring to these errors. And in this slide, I'm going to simply write T1 and T2 in this slide. So anyhow, we have 4 cases, and 2 cases are correct decisions, and there are 2 types of errors. So let's think about an example, diabetes drug. So by the way, as I said, it is just a numerical example, and I have no idea about medical science. It may be totally absurd numbers, so just take it as a numerical example. So suppose that a diabetic drug contains a certain amount of insulin. Suppose that 100 milligram. I don't know how. Maybe milligram sounds too much, but just assume it's 100. And of course, it's important to have the correct amount in a pill. So a hospital or a doctor, researcher wants to test it. So we consider X as a random variable for the amount of insulin in one pill, a pill of drug. And our hypotheses were formulated in this form. The null hypothesis is that the mean is 100 milligrams. The content of the amount of insulin on average equals 100 milligrams, and alternatively, it's not 100. Something is wrong. And I am going to consider 5% significance level, standard deviation of 5, and sample size 100. So, just in case if I gave you the relevant numbers, you may need these informations. Given these informations, what are the critical values? Calculate critical values for this test. And I'm going to stop the video here. After calculating the critical values, continue to the next one. See you in the next video.